are probably actually the easiest type problems that you will be up against in a basic algebra class. But for some reason, it seems to bother a lot of students. So let's try to clear that up. Instructions are to solve for the indicated variable. And for at least one student that I've worked with in my office, she didn't understand this notation. For example, if the equation was x plus y equals z, and then you had this, she didn't understand what this meant. Folks, that's the indicated variable. That's what they want you to solve for. In other words, they're just saying, solve this for x. What comes after this symbol right here is the letter that you want to solve for. So just bring the positive y over as negative y, and you will be done. X is equal to z minus y. That problem is done. You have 2a plus b minus c equals d, and they want you to solve for a. You should identify the terms. I could have said that in the top. Identify the terms, locate the term that has x right there, and bring all the other terms to the other side. Here it is. That's the term that has good old a in it. Bring the other terms over. When you bring a term across the equal sign, change the sign. So 2a is equal to, the d stays as d, the positive b goes over as negative b, and the negative c crosses over as positive c. Okay, think of this as one piece, like E. That's letter E. The 2 is a factor now. Now you have factors. When you cross the equal sign with a factor, when you move a factor across the equal sign, the sign doesn't change like with terms, but the position changes. If you move a factor from the top, when you cross the equal sign, it goes in the bottom. If the factor was in the bottom, you had a over 2 equals to, say, d minus b plus c. It's no longer in the bottom, it's in the top. But it gets multiplied by everything on top. Don't just say a over 2 is equal to d minus b plus c. This guy told me to put the 2 on top. Yes, I did. But as a factor, 2 is not a factor here. 2d is a factor. If you put brackets, then 2 is the factor. It's 2 times this. Those are the 2 factors, the 2 and the d minus b plus c. Okay. But nonetheless, we did solve for a. A equals d minus b plus c all over 2. And we did that right here. It's just, again, move the terms over to the other side of the equal sign if you don't want to remain. I just want 2a alone. I brought the other terms over and I changed the sign. And that left me with 2a equals d minus b plus c. And the 2's on the top, I put it on the bottom. And that's what a equals. If you're doing it correctly, it's as simple as a checker game, possibly simpler. If you're not, if it's harder than a game of checkers, it's not because, oh my, I'm not good at math or I don't get it, because you're not thinking about it the right way. You're not moving the pieces. You are not moving the pieces. If I ask you to solve for b, it's this term divided by that term equals that. So first I want to solve for the term, or the, well in this case the factor that has their a in it. I want to solve for the numerator. I want it to become very, very, very routine. Like you know your name. You want to get rid of the z, it's a factor. It's this divided by that. You can cross this out and put it on top. But this is something I've always been saying. This times w plus z equals the top. So now we know that 3a plus 4b plus c is z times w plus x. Now the left side is made up of terms. This term plus this term plus that term. That's the term that has a. Okay, bring everything else to the other side. I don't care what they look like, just bring them to the other side. If they have a plus in front, put a minus on the other side. If they have a minus in front, put a plus on the other side. So 3a is equal to whatever on the other side, namely z times w plus x. And the new stuff that we're bringing over. The plus 4b, it goes over as minus 4b. The plus c goes over as minus c. The 3 just goes on the bottom. Divide both sides by 3. And there's the answer. Now, if this 3 instead was a b, so it was a capital B, which is different than little b, then you just divide by b, big B. Just divide by b. And this is in a way easier than what numbers. If I gave you numbers, if I said z, 8 times 4 plus 2 minus 4 times 7 minus 11 over 13. That is, if z was always 8 and w was 4 and 2 and b was 7 and c was 11, you'd actually have to do this calculation. But we don't, because literal equations are easier than numerical equations. Okay, let's try another one. But first, you need to understand one step very clearly. If you say had 3 over 2 times 5, well, this is just 3 times 5 over 2. To convince you, 5 is the same as 5 over 1. And, well, 3 times 5 is just what I wrote, and 2 times 1 year, that's 2. Now, if you had a over b times c, this is the same as ac over b. Why? There's an understood 1 there. And a times c is ac, and b times 1 is b. And, of course, well maybe not of course, but if the c was a bit more complicated, say it's c plus d. So like I've always said, think the stuff in the brackets is one letter. Just think of it as e. So it's a times e, or a times c plus d over b. It makes, you have here seeing the 1 there, going. B times 1 is b. So let her solve this problem. Suppose you're told that a is equal to h over 2 times b plus little b. And I want you to solve for little b. But I just want to write it a little bit differently. B plus b. And solve for over 5, and you're being asked to multiply by 8. This is the same as 3 over 5 times 8 written a little bit smaller. That is, it's 3 times 8 over 5. Doesn't matter the size of the 8. Somebody asks you, what is 3 times 14? I don't think you say, oh my, I've never seen such a problem like that. Well, you probably didn't. But nonetheless, when you read it, 3 times 14, oh, that's 42. It's better to have it as a fraction, to solve for any of the variables, it's better to have it as a fraction. That is, this is a times h times big B plus little b over 2. And I'm not sure what happened, I'm sorry. Okay, that's what a equals. That's what a equals. Now, I know that 2a is equal to the numerator. 2a is equal to the numerator. Now, at this point, there's two, so let me write it down twice. There are two reasonable ways to proceed. You can distribute the h. I don't think that's the best way, but if it gets you the answer, great. Now we have 3 terms. Only one of them has a little b. So bring the hb to the other side. It's understood to be plus if there's no sign there. So 2a minus hb is equal to h little b. And then divide by h. And here is your answer. What I would do is, I would bring the factor h to the other side right away. So you have 2a over h equals big B plus little b. Bring the big B over. You have 2a over h minus big B. And that's little b. Now, why do the two answers not look the same? Because on the right-hand side, I have it as one fraction. And if I broke it up, I have the 2a over the h minus the hb over the h. And that equals little b. But then again, these h's cancel. And that's what I have over here. And if you want to get common denominators, you multiply by 1, h over h. And then you can say, oh, denominators are the same, in subtraction, you keep them the same. But of course I didn't do that. Sorry. And then you get 2a minus big B times h. Either way, it's fine. I wouldn't mark it wrong if you left the answer just like this without getting the common denominators. That is, no h's in the red. Now, I'll show you, it's unfortunate that I think it's a trick. I call it a trick because most people don't seem to use this, but it's nothing advanced. For example, if two fractions are equal, so let me write, well, those two are not equal. If two fractions are equal, like 2/3 equals 2/3, if I take the reciprocal of both sides, oh yeah, I get equality. You have 7 over 9, or negative 7 over 9 equals negative 7 over 9. If you take the reciprocal, you'll get 9 over negative 7, so the positive over negative is negative. And if you get negative 9 over 7. Take the reciprocal on the right side, You get 9 over negative 7, an unlisted positive over a negative. That's just negative. You get negative 9 over 7. They're equal. If two quantities are equal, they're reciprocally equal. Of course, there is one exception. 0 over 7, which is 0, does equal 0 over 9. They are equal. But their reciprocals are not. Because this makes no sense and this makes no sense. No sense does not equal no sense. Nonsense does not equal nonsense. They're not equal. That's the only exception. Now, why might this help you to solve equations easily? Let's not so much, let's move a little bit away from literal equations. But if you have 1 over x is equal to 2 over 3, and the reason I say move away a little bit from literal equations, because I can say the indicated variable to solve for is x. But if I take, now these two are said to be equal. They're equal. What is 1 over x equal? You should be able to tell me exactly what 1 over x equals. Just look to see what it says it equals. It equals 2/3. This is 2/3. Like it or not, this is 2/3. If I take the reciprocal of 2/3, on one hand I get x over 1, which is x, and on the other hand I get 3 over 2. I have what x equals. It's amazing what a lot of algebra teachers will tell you to do. They'll tell you to cross multiply. Now you get 2x is equal to 3, and now divide by the 2. And we get the same answer, but taking reciprocals is pretty cool. Take the reciprocal of this side, get that. Take the reciprocal of x, 1 over x, get x over 1 or x. Problem is done. Problem is done. Okay, even if you had 4 over x is 7 over 11. I would take the reciprocal of both sides. Now I have x on the top. Remember, the denominator times the other side always equals the numerator. That is, x is 4 times 11 over 7. 44 over 7 in this case. That's what x equals. If x is in the bottom, take reciprocal. Take your reciprocal of both sides. So, back to literal equations. I told you 3 over a is 4 over 5, and I asked you to solve for a. Take reciprocals. A over 3 is 5 over 4. And then just bring that factor to the top. And there's the answer. A is 15 over 4. We should be able to do it where more letters. A over B is equal to C over D. Solve for B. Since B is in the bottom, I would immediately take reciprocals. And then I'll say, oh, but the A is in the way. Now I just have B if I didn't have the A. The A is a factor. It's on the bottom, I put it on the top. There's the answer. B equals dA over C. It really should become a natural process that you use when needed. When you have to see when it's needed. As a student of advanced math, maybe somebody will say, well, state that rule. I don't think you know it. And I would just state it completely correctly. But the thing was that I wasn't using it. The reason my teacher asked me to state it was because she didn't think I knew it. But I knew it, but I wasn't using it. Okay, we want to solve for x. Now, I guess we should talk about it right here. A third plus a half. that equals to 5/6. That equals to 5/6. Now, if I take the reciprocal of the right side, it's kind of obvious what I get. I get 6/5. Now, so the reciprocal of the left side is equal to the reciprocal of the right side. The reciprocal of the right side is 6/5. But now, reciprocal does not distribute over plus. That is, you can't take the reciprocal of 1/3, which is 3, plus the reciprocal of 1/2, which is 2. Because 3 plus 2 is 5, and it doesn't equal to 6/5. You can't distribute reciprocals over addition. That is, first you would actually have to do the addition or subtraction. Our 1/2 minus 1/3 is, I think, a 6. 3/6, well, yeah, is a 6. So the reciprocal of the left side really does equal to the reciprocal of the right side. The reciprocal of the right side is 6. But it's not the reciprocal of 1/2 minus the reciprocal of 1/3. This is -1, this is 6. They're not equal. If you have one fraction equals another fraction, then you can just take the reciprocals. This is not one fraction. This is, but this is not one fraction. When it's one fraction, then taking the reciprocal is easy. Just top goes to bottom, bottom goes to top. Okay, so if somebody asked you, what is the reciprocal of 1/2, 1/3 plus 1/2? If somebody asked you on an exam, what is the reciprocal of this plus that? First, you should add it. Get whatever you get. And then take the reciprocal of that, which is 6/5. So that's the problem we're having here. We just can't go and say, oh, x is in the bottom. I see x in two places. They're in the bottom. So I'm going to take reciprocals. The reciprocal of the left side might be this. But the reciprocal of the right side, thinking this as 5/1, is not 1/5 plus x over a plus b. It's not. Okay. So unless you have one fraction, not the sum of two fractions, if you have one fraction equals another fraction, then and only then can you take their reciprocal. If somebody asks you, what is the reciprocal of 2 plus 3? Well, is it the reciprocal of 2 plus the reciprocal of 3? The reciprocal of 2 is 1/2. The reciprocal of 3 is 1/3. And this is 5/6. Well, 3 plus 2 is 5. So the reciprocal of this is the reciprocal of 5. Remember, 5 is 5/1, which is 1/5. That's the correct answer. This one is not. You cannot do that. You cannot do that. Okay, having said that for 3, 4, 5 times, let's actually do this problem. Let's get all the x's on the same side. Let's bring this to the other side. So you have a minus b over x is plus. When I bring it over, it becomes minus. And this is still 5. So we know we're over x and it equals 5. You have a, and you take away a, you have 0. You have negative b, and you take away b, you took away 2b. And now, since I have one fraction equals another fraction, now I can take reciprocals. And I'll even put the negative on the bottom, because I really want x alone. this is 1/5. Cross this out and put it in the top. And 1 times negative 2b is negative 2b over 5. That is what x equals. Okay, once I had one fraction equaling another fraction, and you want to take reciprocals, because x is in the bottom and you're being asked to solve for x. Take reciprocals. Get x in the top. Now, in electronics, when it comes to calculating the resistance, I forget if it's in series or in parallel, but sometimes you have an equation like this that you need to solve. 1 over a plus 1 over b plus 1 over c. And say you want to solve for b. And a would be, say, the first resistance plus 1 over the second resistance. This would equal to 1 over the total resistance. If you want to know the total resistance, well, the reciprocal of this is just RT, the total resistance. You need to find the reciprocal of that. Okay, maybe a better problem would have been to solve for C, but let's solve for B anyways. So these are the 3 terms. This is the one that has B in it. So bring that to the other side. 1 over B is 1 over C minus 1 over A. And I'm all ready to take the reciprocal of the left side, because the instant I do it, I get what B equals. But the right side is delaying me. The right side is definitely delaying me, because it's not one fraction. The LCD would be C times A. I need to multiply the first fraction by A over A. Then I'll have CA in the bottom. And the second fraction by C over C, which is 1. Okay, so the first fraction is A over CA, or AC, minus the second fraction will be 1 times C over CA. That is, I have 1 minus C over CA equals 1 over B. 1 fraction equals 1 fraction. Reciprocals. CA over A minus C. And that's what B would equal. Okay, that finishes the section on literal equations. Find the term that has the indicated variable, or the terms that have the indicated variable. Get them all on one side of the equal sign, and everything else on the other side. And then move the factors. All right, good luck with this.